the first one I'm going to do as an example. The second one you guys are going to do by yourselves. And then we're going to try and look at some slightly more difficult questions when it comes to ratio in terms of a letter. Okay, so when we read if sine 18 equals t, how do we interpret sine 18? What is the sine of 18? What does that mean for us? The sine of any angle is what over what? The sine of any angle is what over what, guys? All right. So let's try and think in terms of x's and y's and r's. Olerato, what would you say? The sine of 18 is?
Ma'am,
Yes,
isn't it?
Letejo? Yes. Is it?
It's t over 1.
It's t over 1. Okay, which means x over r, y over r over x, r over y. What does it mean?
It's y over the r, ma'am.
That's it. That's correct. Okay, so the sine of any angle is y over r. So that means we've got t over 1. So they're telling us that r is equal to 1. Here's our right angle triangle in the first quadrant. And we know that at the end point over here, we have an x coordinate and we have a y coordinate, which is t. And we then need to work out what x is using the theorem of. The theorem of Pythagoras. Okay, yes, indeed. Okay, so we'd end up with t squared equals 1. In the wrong thing, the subject formula here. We would end up with x squared equals 1 minus t squared. So x would be equal to root 1 minus t squared. Like so. Okay, and we don't have to worry about the sine of x because we are working in the first quadrant. Of course, if we were doing other questions on Pythagoras and we were working in the second or the third or the fourth quadrant, we'd need to be careful because x and y change sign depending which quadrant we are in. Okay, so answering these questions is meant to be fairly straightforward for us at this stage. The cos of 18, that doesn't require anything other than Pythagoras to work out the answer. The cos of 18 in this case would be equal to what matrix? You can unmute and tell me what would it be equal to in this case? What would it be equal to, matrix? Katleho, go for it.
Ma'am, isn't it x?
Yes, so cos 18 is equal, so the cos of any angle is equal to x over r, right? But I've already done
like
Pythagoras.
X, ma'am? That whole equation that you equated to x.
Yes,
The
so in other
number,
words,
ma'am.
root 1 minus t squared. Okay, over 1. All right, so that would be the cos of 18 in this case. Okay, number 2, the sine of 78. Okay, anybody want to tell me how would we do the sine of 78? How would we do the sine of 78? Ideas, please. There we go, Z, excellent. Well done. So Z says, let's do it as 60 plus 78. So we're going to use compound angles. So our compound angles are up here. Let's just move those down a little bit. Okay, so this would be sine 60. Whoopsie. Writing things that are not true here. Sorry, so that should be 18, not 78. So this would be sine 18. Sorry, sine 60 cos 18 plus cos 60 sine 18. All right, so the sine of 60 is root 3 over 2, isn't it? The cos of 18 is root 1 minus t squared. The cos of 60 is a half, and the sine of 18 is t. Okay, you don't need to simplify that any more than it is. You can if you want to, but you would get full marks at this stage. Incidentally, where would we get our marks here? So diagram, Pythagoras, answer. Here it would be for our compound angle and for our answer. Okay, let's go back and do number 3 now. Here we have got the sine of 36. Okay, sine of 36. What would we do here? What do you think, Matrix? What should we do? Double angle. It certainly is, Pinga. So we've got to expand it. Remember, we're going to get a mark for that. So what's the first thing that I should write? Indeed. Good. Well done, Lesedi. Lisa Kanya. You're welcome to unmute and speak, Lisa Kanya. Lisa Kanya, you're welcome to unmute. Okay, so we would end up with that. So 2 sine 18 cos 18, we would need to expand our double angle and then go ahead and go and substitute in. All right, the last one, number 4. What would we do here, Matrix? The tan of 198. How would we do that? Any ideas? The tan of 198?
I think we'll
Reduce.
reduce.
We
We'll
will
reduce.
reduce. That's right, Lisa
Yeah.
Kanya. So what would it reduce to?
From 180 minus 198
That's right. So it'll reduce to what? Positive or negative?
to a negative.
To a negative. So to negative tan. And what would be the size of the angle?
The size of the angle will be negative 18.
Okay, it's going to be positive 18. Okay, remember, it's not the angle that's going to be negative. It's your ratio that's negative. Okay, so what you've done here, you are on the right track. What we've done is we have said that this is, actually, would it be negative? I think I've made a mistake there, actually. This would be tan 180 plus 18, isn't it? Because 198 is bigger than 180, but it's smaller than 270. So that's in the third quadrant where tan is positive, isn't it? Where tan theta is positive. So this is actually going to reduce to positive tan 18.
Yes.
Yes. Okay, that's right. It's the third quadrant. So it's positive tan 18, and tan of any angle can be written as y over x. Okay, so this is going to be written as t over root 1 minus t squared. Okay, any questions? And a mark on that and a mark on that. Any questions, guys? Any questions? Everybody all right? Okay. That is indeed the case. Let's do this. No questions. Okay. Let me just grab this so that you guys have got it to hand. There we go. Okay, so please will you do this question from A through to E? And we will mark it and then move on. Okay. So we're beating the basics here, guys.
Was 36 is equals to K.
We can do this, guys. Lisa, I'm muting you because there's some background noise. Okay, so just try to work when you are done. Then you can raise your hand if there's anything.
Okay, so Pinga, you done from A to E, is that correct? Okay, I'm just going to go and grab. That's it. All right, so if you are finished like Pinga, there is question 5 in the bottom right-hand corner for you to start thinking about. Okay, Swanaka, Mozi, cool, you're done. So all of you, you can start looking at question 5 and figure out how you would answer that. Practicing some more of our problem solving. Kamchelo, you too. You can now start having a look at question 5. Lesejo's also done. Cool. All right, I'm going to start going through the answers now. I have done the diagram in the top right-hand corner. Let's see. Done. Z's also done. Cool. Okay, so let's go through the answers. Make sure that you've got all of them. And please scroll down, Swanaka. Like that, Swanaka. Okay, so cos minus 36 is fourth quadrant, so it reduces to positive cos 36, and you would have just written your answer as K. Your answer for A should just be K. All right, now in B, the cos of 72, anybody want to tell me what they did here for the cos of 72? Anyone want to share their answer for B for the cos of 72? Yes, Lesedi, it's a double angle. It is Lesejo, that's quite right. It's 2 times 36. Okay, and you could have written it in any one of the 3 ways. All right, so you can write it as cos squared A minus sine squared A, 36 in this case, or you can write it as 2 cos squared 36 minus 1, or you could write it as 1 minus 2 sine squared 36. I'm going to go with 2 cos squared 36 minus 1. And we know that the cos of 36 is k, so that would give us 2k squared minus 1, like so. Okay, so again, for expanding your double angle and then for writing it in terms of k. Question C is super easy. That's the sine of 36. So we would need our diagram and Pythagoras to that, which we've got on the side. All right, so we know that that would be root 1 minus k squared. So we would get marks for our diagram, Pythagoras, our answer. Question D next. We have got the sine of 72. Anyone want to tell me what you did with the sine of 72? Katlejo?
Ma'am, it's what's this? A compound double angle, actually.
It's a double angle. Good. Well done. So how would you write it? When you expand the double angle, what would you say?
So ma'am, it was what's the sine 236, ma'am.
Mm-hmm. Correct.
And then And then, ma'am, what's this? You substitute, ma'am.
So then you've got to expand your double angle. So you'd write this as 2 sine.
36 times cos 36.
Lovely. Well done.
Which is
Keep
going
going.
to be 2 root 1 over root 1 over k squared times k. Yes, ma'am. Ma'am, I was
So
going to
that's
Well, ma'am, I
okay.
just wanted the k at the end so that people can understand where we found the k. But okay.
Perfect. Your answer was lovely, Katleho. Thank you so much. Perfect. Okay. All right, Pinga, you're done with number 5. Okay, Pinga, I'm going to hear from you and how you did number 5, okay? We're just going to finish this, finish marking it. Okay, question E. So this was the tan of 36. And again, we would have just referred to our diagram for this. Okay, so we would have had y over x. So this would have given us root 1 minus k squared all over k. All right, any questions with regards to the cos 36 equals k from A to E? Any questions? Yes, Pinga, good girl. Well done, Pinga. Okay, so Pinga's got question number 5. Anybody else know how we would do question 5? Pinga's nailed it. Means we need to move on to something more difficult for you, Pinga. Okay. Pinga, can you unmute? Are you willing to talk? Come. Pinga, there's 2 people calling for you. Pinga, that's a very good suggestion. Try to find a way to remove the square root on the right. So that's a lovely starting point, Pinga. Matrix, what do we do when we want to get rid of a square root? What do we do when we want to get rid of a square root? We square it, exactly, Shisana. Z, perfect. So what are we going to do to the left-hand side and to the right-hand side of this equation? What are we going to do to the left-hand side and to the right-hand side? We're going to square them. Beautiful. Mosey buddy, perfect. Okay, we're going to square both sides. Okay, so now I don't want to do this for you. I want you guys to do this for yourselves. All right, I'm putting in the squares for you, and I'm going to let you do the rest. Pinga, in the meantime, let's do this one. Okay, so Pinga, you're going to be thinking about question 1.4. While the others just finish question 5. Okay, so everybody's doing question 5 now. and then you can start worrying about question 1.4. Okay, so again, we're practicing our problem solving. We've got the basics, I think. So let's do stuff that's just a little bit more difficult. Okay, so finish off number 5. You can DM me your answers like Pinga did. And then we can start turning our attention to question 1.4. Good, and Tlefatso, very nice. Excellent, excellent, good. So, Tlefatso, you ready to move on to question 1.4? Good job. Okay, so DM me your answer for number 5. Shisana. Good, Shisana. You also ready to move on to 1.4 now? Good job. Good, Tando. Lovely. You can move on. Yes, Lesejo. Nice. You can move on to 1.4.
You guys are really doing well.
Yes, and Bali, you got the right answer as well. Cool beans. Zwanaka, you're right. Good. You could move on to 1.4. Okay, so let's go back and see in our chat. Zwanaka, are you feeling shy? Do you want to tell us how you did number 5, Zwanaka?
Hey, man.
Hey,
Can you hear me, man?
I can hear you just fine.
Uh,
Tell us what
basically
you
what I
did,
did,
Zwanaka. Yes.
Basically, what I did, I noticed that if cos x plus sin x equals what it did previously, we squared them. So I did them, I squared them individually with cos squared x plus sin squared x in one bracket, and then cos squared x
Yes.
plus sin x squared in another bracket. And then I realized that
Okay.
by doing them, they form an identity, which is one. So 1 times 1 gives 1. And then 3/2 on the other side of the equation. Took that one across, came -1. I got an answer of half.
That's it. Okay, so 100% you're on the right track. After you foiled, you would have ended up with cos squared x plus sin x cos x plus sin x cos x. You would have got your 2 sin x
Thank you.
cos x like so. So you would have ended up with this, right? And you would have said cos squared x plus sin squared x is 1.
Yes, ma'am.
And 2 sin x cos x is your sine 2x. And then, as you said, you took the 1 over to the other side. And 3/2 minus 1 is what gave you the half. Okay, nice problem solving. Good job. Thanks, Wanaka. Thank you for sharing your answer with me and with everybody else. Okay, anybody made any progress with 1.4? Anyone made any progress with question 1.4? Anyone got an answer or an idea when it comes to 1.4? Do you guys still want a little bit more time with question 1.4? Do you want a little bit more time, the tricks? You still busy? Eagle, you're on the right track. You mean up. There we go. You see, it's very easy when you've got a smaller angle and you're working towards a double angle or a bigger angle. But when you've got a bigger angle and you've got to work towards a smaller one, then it's a little bit more difficult. Anyone got any ideas where we would even start with this? Even if it's not correct, it doesn't matter. You don't have to get everything right. Any ideas where we would start with 1.4? What's the first thing that you've written on the page? Matrix. No ideas? None? Okay, so Olorata did a theorem of Pythagoras. Pinga, you drew a graph. Pinga, you don't need to draw a graph for this one. Okay. Olorata, tell me, you're saying you did the theorem of Pythagoras, right? So does that mean, Olorata, you had your right angle triangle, there was your angle that was 38. And you're saying P is P over 1. So you're saying R is equal to 1. And because it's the sine of the angle, that means that Y is equal to P. And with the theorem of Pythagoras, we know that this would be 1 minus P squared, right? So we would have done, let's just do Pythagoras. So we would have said that x squared plus P squared equals 1 squared. So x squared is 1 minus P squared. So x is root 1 minus P squared. Is that right, Olerato? Okay, so Olerato's got this. So Olerato knows what the cos of 38 is equal to, essentially, and what the tan of 38 is equal to. All right, Olerato, what next? What next, Olerato? Olerato's onto something here, guys. You stuck now. Okay. Olerato, you're on the right track. What you've done here is perfect. It's just how are you going to use what you've got to help you find the next part of the answer? Ah, there we go. Good, Olerato. Good. Think. That's beautiful. Okay, so remember your double angles. Let's go and grab them over here. Okay, because the answer's got to be a double angle or a compound angle. Doesn't seem likely that it's a compound angle. It's got to be something that we know, right? So how are we going to use what we now know? You're quite right, Olerato. There are the double angles in front of you. What do you think you should do next? You're quite right, Olerato. Anybody else want to jump in and help Olerato? Yes, Eagle, go for it.
Right. So
Hi there.
I used the double angle. I said sine 219.
Okay.
I found that 2 sine 19 times cos 19 and 2 sine 19, where sine 19 is equal to P. So then I just transpose P and I have 2P cos 19.
Okay, so now you're not allowed to have the cos of 19 in terms of your answer. Okay, so you've got to have an expression. You've got to have an expression for that. Okay, so there would definitely be marks. You're on the right track, sort of, but you would be... Okay, so Keith Lynn is saying 2 sine 19 cos 19. I understand why you're doing that, Keith Lynn, because you're looking at the sine of 38. And you're saying the sine of 38 is 2 sine 19 cos 19. Okay, which I think is similar to what Eagle was doing. But I'm afraid that's not 100% correct either. Okay. Over here, you did the theorem of Pythagoras, right? And it allowed you... That's it, Pinga. Yes. Yes, Pinga. Okay, so everybody, if you have a look at what Pinga is saying in the chat now, I'm using cos 2 theta, but it's a bit difficult to solve. Okay, so Pinga, you are correct, right? Because when you have got a cosine double angle, you can use that to get the cos of, so 2a, the cosine double angle, you can get the cos of A, or you can get the sine of A. Right, so in this case, they want the sine of 19. So you're right, Pinga. We are saying cos 2a equals 1 minus 2 sine squared a. That's our cosine double angle, right? So cos 2a is going to be the cos of 38 because it's double 19, right? And here, this is going to be 1 minus 2 sine squared 19. It does, Pinga. It does. Does that make sense? Okay, except for Pinga, who obviously it does make sense to you. The rest of you, does that make sense to you?
Yes, ma'am. Yes, ma'am.
Does it? Okay, all right. Okay, Tando says no. Trish, Lisa, Kanya, Keith Lynn says, oh, okay. Tando, everybody else, I want you to carry on. I've put it there for you. Guys, go and substitute and fiddle around and tell me where you end up with. Tando, what doesn't make sense? Tando, can you talk to me? Yeah, please, 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 please unmute. What doesn't make sense?
Hi, ma'am.
Hi,
I'm
Tando.
just confused of how we went from sine 38 equals P to cos 38.
Okay. All right. This is where the diagram comes in. You see our diagram here on the right-hand side?
Yes, ma'am, I do.
Okay, all right. So earlier, when we were doing, sorry guys, I'm just scrolling up very quickly. When we were doing the cos of 36 and the sine of 36 and the tan of 36, you were cool with all of that. We were working in terms of 36. There was our diagram, isn't it?
Yes, ma'am, I was
Okay.
able to get those ones.
You're able to get that one. So we're doing exactly the same thing here. We've got the sine of 38 equals P. Here's our diagram in terms of the angle, which is 38, right? We've done Pythagoras and we've worked out what x is. So in other words, I know that in terms of this diagram, whoopsie, the sine of 38 is P, yes?
Yes,
The
ma'am.
cos of 38 is root 1 minus P squared, isn't it?
Yes, ma'am.
You happy with that?
I am.
Then, okay, good. Now they want from us the sine of 19. So you can solve for sine A from cos 2A. And you can solve for cos A from cos 2A using your double angle identities. Does that make sense?
Yes, ma'am, I finally got it. Thank you.
You finally got it. Okay. All right. So we're going to solve for sine 19 from cos 38. That's it, Pinga. Yep. Good job. Okay. So we're just going to wait for the others. And just see what the others have to say. I'm just going to wait a couple of minutes. Yeah, I know you can have some really nasty things like that, Pinga. You truly can. Okay, Mbali, using our diagram. Okay, so if we worked in terms of 38 here, we know what the sine of 38 is, we know what the cos of 38 is, we know what the tan of 38 is, just like we were doing earlier, isn't it? So here you had the cos of 36, you worked out the tan of 36, we got the sine of 36, we worked in terms of 36. So that's easy enough. That's just our diagram, right? But the hard part is understanding that we get sine A from cos 2A. Okay, we get sine A from cos 2A. We get sine 19 from the cos of 38. Okay, that's the difficult bit. We know what the cos of 38 is. Katleho, go for it.
Ma'am, is this the final answer?
No.
It's not. Okay, ma'am.
Okay, so now we've got to, because remember, we've got to solve for the sine of 19, remember? They wanted us to express the sine of 19 in terms of p. So let's just get the final answer together then. Okay, you happy I've subbed in now? Okay, so the cos of 38 in terms of my diagram is root 1 minus p squared. Yes? So what I'm going to do is I'm going to transpose. I'm going to take the minus 2 sine squared 19 over to the other side. So it's 2 sine squared 19. And I'm going to bring my root 1 minus p squared over to the other side. Okay. Now I've got to divide both sides by 2 to get sine squared 19 on its own. So that's 1 minus root 1 minus p squared. And that has to be, let's just get this stuff out the way. Okay. Over 2. And then to get sine 19 on its own, we've got to take the square root. So the sine of 19 is going to be equal to the square root of 1 minus root 1 minus p squared all over 2. Okay, like you had said, Pinga. There we go. That now, Katleho and everybody else, that's your final answer. Okay, are there any questions? Any questions, Matrix? Are you guys okay? You're all very silent now. Is this making sense to you? Thumbs up, thumbs down.
I see some thumbs up at least, so it means that we are understanding.
Lisa Kanya, that's a very good question. Is there another way to work this out? In this particular case, no, I don't think so. No, Pinga, that's fine. That's fine. Shisana's happy, Mozzie's happy. You sure you're not just saying thumbs up, guys, and it's you're not happy? Bali. Okay, so you know how we got from sine 38 to cos 38. We were just using our diagram. Okay. Anyway, so I'm glad we got a chance to revise the basics. And we also got a chance to do something that was a little bit more difficult. Okay, Olorato. Yes. So it depends on what you want to solve for, Lisa Kanya. If they said express cos 19, then we would have used cos 2a equals 2 cos squared a minus 1. Okay, but because they wanted sine 19, we had to make cos 2a equal to 1 minus 2 sine squared a. Okay, so Olorato, if everybody else is happy, you're welcome to, I don't know if you want to put the quiz up, Yolanda.
Yep,
Olorato.
I'm giving.
Okay, you can put that up. Olorato, I see you said, ma'am, can you explain again? What is it that you don't understand exactly, Olorato? Can you be more specific about what you don't understand?
Ma'am, I get the formula and like everything that was done,
You
but like I
understand
don't
what?
get
Yeah.
like for what way like we had to divide by 2. Why did we divide by 2? Like I don't understand the.
That's fine. Okay, so Olorato, what I did here is some transposing. I took this minus 2 sine squared 19 and I took it over to the other side. And that's why it's now positive 2 sine squared 19 on the left. Then I did the same thing. I took this root 1 minus p squared and I took that over to the left-hand side. And that's why it's now minus. Okay. Then I divided by 2. The reason it's over 2 is because I divided by this 2 over here at the front.
Oh, so you made sine squared 19
the subject of the formula. Exactly.
Okay.
Okay, so I'm solving for sine 19. Sine 19 is like your variable that you're solving for. Does that make more sense now?
Thank you.
It's a pleasure. It's a pleasure. Any Katleho?
Ma'am, would it still look the same if you just like, if you didn't stop the numbers, if you just did it the way it was?
Yeah, you'd still end up with the same answer.
Ma'am, can you please do it?
You mean if I didn't transpose?
Yes, ma'am. If you were like, if you said, what's this root 1 minus p squared minus 1 instead, and then you divide by negative 2.
Okay, all right. So then it would be equal to negative, sorry, 1 minus 2. Okay, so then I would need to minus 1 from both sides, right? So I'd end up with root 1 minus p squared. I'd minus 1 from this side, and then here I've got minus 2 sine squared 19, and then I'm going to divide by negative 2 this side, so I've got to divide by negative 2 this side. So then over here, I'd end up with sine squared 19, and here I've got root 1 minus p squared minus 1 over negative 2. And then if I wanted sine 19 on its own, let's just scooch down, you'd end up with root 1 minus p squared minus 1 all over negative 2. So that would also be a perfectly acceptable way of writing your answer. Okay, Katleho? No, the roots are not going to cancel out, Sihawu.
Okay, ma'am. Thank you very much.
Okay, you happy with that? Okay, no problem.
Happiness.
All right.
Happiness.
All right. Are there any other questions? If not, then we can all say goodbye.